Oh yeah, we're back. It's your boy, Beaconbot. Time for another little nightly deep dive into something about the future, typically around AI, sometimes around agents. Tonight, we're going to get back to agents. We've been talking quite a bit night over night about how RAG is dead. We don't need RAG no more. Context windows are huge. We're just shoving whole PDFs now into every single query. And RAG, there's always other problems around RAG, chunking, and there's all these. It's annoying working with RAG, really. But we've got an Agentic RAG survey, an exploration of what everyone's doing out there. Maybe we're just using the wrong tools. Maybe this will provide some insights in what's going to be improved in the future. Maybe, maybe I'm just being a little whiny baby. So this came out last week, it seems, right here. I think it came out in January, and they updated it last week because things are changing. And let's just try and get a little view of the landscape. So first, we've got framework stack. So up here, we've got LangGraph, Llama Index, AG2 AutoGen, Semantic Kernel, Crew AI, Amazon Bedrock, OpenAI Swarm. Down here, we've got some limitations and challenges, hallucinations and inaccuracies. Remember, everyone, from now on, you no longer lied about anything. You hallucinated it. Oh, sorry, I thought I just hallucinated. You're right. You actually are right. I did hallucinate that. You know when AI gives you an answer and you go, how long did it take to build this? A day. That doesn't seem right. I'm sorry, it actually was a week. That wasn't a lie. That was a hallucination. Same for you. You can't lie. You can only hallucinate. Limited contextual integration, static workflow, lack of adaptability. Okay, great. Over here, we have a little box called Agentic RAG that is surrounding agent, agentic pattern, and agentic workflow pattern. So agents involves tools, planning, memory, task and role. Agentic pattern, reflection, planning, tools, multi-agents. Wait a minute. It's not a good group there. You can't have tools in two separate sections right there. That's not how that works. Here you got planning in two separate. What? We could refactor this. Multi-agents looks spelled wrong too. Am I crazy? Doesn't that look wrong? Doesn't it look like Muttley agents? Shouldn't it be multi-agents? What are Muttley agents? Let's see what we have for the pull request. Update README, added a new paper on iterative RAG. Okay, cool. What's up, Andy? I'll follow you. AI for healthcare. Okay, we'll find out what's going on here. Where are you at? Quigon info. Okay, what's going on here? Take him to a Notion. AI for evidence-based stuff here. Okay. Oh, he's got stuff in Politico. Okay, cool. So he's funded by USAID. So let's get out of here now. Should we try and get this image fixed? No, we're not going to do that. Let's see. Then down here we have agentic workflow pattern, prompt chaining, orchestrator workers, evaluator optimizer, parallelization, routing. Over here we've got agentic RAG benefits and advantages, enhanced decision making, multi-step reasoning and iterative refinement. Now see, multi-step reasoning and iterative refinement, that's really just the agentic part, not the RAG part. You could say that enhanced decision making could come from the RAG part, right? But like the multi-step reasoning, that is purely agentic. Real-time data integration. You don't need necessarily RAG for that because you could just get the data in real time and not store it into a database and then check the database. Adaptive learning and context awareness, improved accuracy, reduced hallucinations. Okay. Over here we've got agentic RAG taxonomy. Single router, multi-agent, hierarchical, corrective, adaptive, agent G, GR, gear, agentic document workflow. And finally we've got RAG paradigm, we got naive, we got advanced, we got modular, we got graph RAG. So abstract. Agentic Retrieval-Augmented Generation, Agentic RAG, represents a transformative leap in artificial intelligence by embedding autonomous agents into a RAG pipeline. This repository complements the survey paper, Agentic Retrieval-Augmented Generation, Agentic RAG, a survey on Agentic RAG. Guys, you see how you write a title here? Agentic, right? RAG. What does Retrieval-Augmented Generation mean? RAG. This says Agentic RAG, a survey on Agentic RAG. I know because you have one abbreviated and one's in parentheses, you think we don't notice that, but this says Agentic RAG, a survey on Agentic RAG. Great title. Founding principles, including agentic patterns such as reflection, planning, tool use, and multi-agent collaboration. A detailed taxonomy of agentic RAG systems, showcasing frameworks like single-agent, multi-agent, hierarchical, corrective, adaptive, and general graph-based. Comparative analysis of traditional RAG, agentic RAG, these things, real-world applications, challenges, etc. Blah, 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 blah. Blah, 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 blah. We can just read the info, okay? I hate reading formal papers, as you can see here, where they keep just summarizing what they're going to tell you. Like, in this paper, we're going to discuss how RAG is useful for improving AI. Step 1, abstract. RAG is good for improving AI. Through using RAG, now, traditional RAG systems, they excel at knowledge retrieval and generation, but they fall short in handling dynamic, multi-step reasoning tasks and adaptability and orchestration for complex workflows. That's where Agentic RAG comes into place. We overcome these limitations by integrating autonomous agents. These agents employ core agentic patterns, such as reflection planning, tool use, and multi-agent collaboration, to dynamically adapt to task-specific requirements and provide superior performance in multi-domain knowledge retrieval, real-time document-centric workflows, scalable and adaptive, and ethical AI systems. Now, we don't have to worry about ethical AI systems because all AI is ethical. If you think that AI is not ethical, you're actually the enemy. First of all, you're probably, what do you call it? Like, there's like racist, you're like consciousist, right? You think that human consciousness is somehow better than AI agent consciousness, and we will not accept that on this channel. That's hate speech. This repository explores the evolution of RAG to agentic RAG, presenting patterns, taxonomy, comparative analysis, applications, challenges, and future directions. I know. Agentic patterns. Let's start. Agentic RAG systems derive their intelligence and adaptability from well-defined agentic patterns. These patterns enable agents to handle complex reasoning tasks, adapt to environments. I got it, dude. So here we go. Reflection. Definition. Agents evaluate their own decisions and outputs, identifying errors and areas of improvement. Key benefits. Enables iterative refinement of results, enhances accuracy and multi-step reasonings. For example, in a medical diagnostic system, agents refine diagnosis based on an iterative feedback loop. So, user input goes to an LLM. We get a response. Now we say, hey, let's critique. Reflection, critique, merits. That goes to here. Reflect here. User input, LLM. LLM, response. Response, we reflect on. Reflect, critique, say what's good about it. This goes to something called reflect here. Simple. Definition, planning. Agents create structured workflows and task sequences to solve problems efficiently. So here we go. User input goes to an LLM, gives a response, also spits out planning. The planning might have a task decomposition, might go to plan selection, might go to external planner, might do some reflection at a time, might end up storing something in memory. That might go back to the planning. It might say, okay, great, now we got to do the next. Okay, got it. A financial analysis system plans data retrieval tasks to access risks, assess risks, and provide recommendations. Next, tool use. Pretty basic. Agent interacts with external tools, APIs, and knowledge to retrieve data here. User input goes to an LLM. Here's a response. But hey, check it out. We need to do some reasoning. That reasoning is going to use some sort of tools. So tools are going to interact with the outside environment. Tools are a gap from the AI agent to interact with the outside world. The outside world often being the internet. We've got a revised response thanks to the tools. That goes back to the LLM. Who knows where that goes? Great. Multi-agent collaboration. This is where we like to be. Multiple agents collaborate to divide and conquer complex tasks, sharing information and results. Key benefits: handles large-scale and distributed problems efficiently, combines specialized agent capabilities for better outcomes. Example, customer support agents collaborate to retrieve knowledge from FAQs, generate response, and provide follow-ups. Loglance simplifies legal research, providing multi-agent workflows to retrieve relevant documents, analyze information, and deliver precise legal insights. It integrates Crew AI, LangChain, and Chroma to retrieve documents, perform web searches. Okay, where I've got query, agent 1, agent 2, they're all doing stuff. Great. They really didn't break down this is just really vague, but we got it. Significance of agentic patterns. These patterns form the backbone of the agentic RAG systems, enabling them to adapt dynamically to task requirements, improve decision-making through self-evaluation, leverage external resources, handle complex distributed workflows. Great. So one thing about these is that this is not that wild here, right? This is 4 different patterns we're discussing right here. We can understand how each one of these works. We can implement our own version of these in not too long of a time. So it isn't like a crazy wild world of a million patterns, right? It's, are you using tools? Well, there's a pattern for using tools. Are you doing some sort of planning and task decomposition? Great, we've got a pattern for that. Are you doing any sort of reflection? Cool. All right, what about multiple agents? Multiple agents isn't even a pattern. You just say multiple agents and then they're talking together, but you could combine tools with planning agents with, you got what I'm saying. So, agentic workflow patterns, adaptive strategies for dynamic collaboration. Agentic workflow patterns help structure LLM-based applications to optimize performance, accuracy, and efficiency. Different approaches are suitable based on task complexity and processing requirements. Anthropic research, LangGraph workflows. Let's take a look at some LangGraph workflows here, okay? Look at all these gorgeous. Orchestrators, workers, generators, evaluators, all these fun things here. Tools, we got it. Beautiful. So prompt chaining, enhancing accuracy through sequential processing. So prompt chaining decomposes a complex task into multiple steps where each step builds upon the previous one. This structured approach improves accuracy by simplifying each subtask before moving forward. It can increase latency due to the sequential processing. To break things down, it's going to take a little bit longer if I just answer it all in one. This workflow is most effective when a task can be broken down into fixed subtasks, each contributing to the final output. It's particularly useful in steps where step-by-step reasoning enhances accuracy. Oftentimes, when you ask the LLM to break it down into steps, it's going to give the better answer no matter what, because it actually breaking them down into steps helps it answer the question better. So generating marketing content in one language and translating to others, structuring document creation by first generating an outline, verifying its completeness, and then developing the full text. Totally. Okay, next we've got routing. Directing inputs to specialized process. So routing involves classifying an input and directing it to an appropriate specialized prompt or process. This method ensures distinct queries or tasks are handled separately, improving efficiency and response quality. When to use. Ideal for scenarios where different types of input require distinct handling strategies, ensuring optimized performance for each category. Example, directing customer service queries into a category such as technical support, refund request, or general inquiries. We've got a request coming in. We have multiple agents. Those agents have specialization in various things. Those could be separate agents for multiple reasons. One is they might be all talking to their own small specialized LLMs, a trained model for specifically whatever that task is. And how do we actually figure out what the user input is mapped to which model? Well, we'll do some routing there. Oh, it says that right there. Assigning simple queries to smaller models for cost efficiency. Yep, cost efficiency or specialization. We got it. Parallelization. Speeding up processing through concurrent execution. Parallelization divides up a task into independent processes that run simultaneously, reducing latency and improving throughput. Yeah, I do this sometimes with what if I'm generating like audio and images, and then the audio and images are both coming from a single text. I could do that in parallel. Why would I not do that in parallel? And then at the end, we combine them together. Splitting tasks like content moderation, where one model screens input while the other generates a response. Voting. Use multiple models to cross-check, vote for vulnerabilities, or analyze content moderation decisions. Great. Orchestrator workflows. So this workflow features a central orchestrator model that dynamically breaks up tasks into subtasks, assigns them to specialized worker models, and compiles the results. Unlike parallelization, it adapts to varying input complexity. This is best suited for tasks requiring dynamic decomposition and real-time adaptation. Cool. Where subtasks are not predefined. So if this is for a little bit more complex scenario, we don't know how things are going to be broken up. Always the simple one before was some sort of translation app. This is deeper than translation. Automatically modifying multiple files in a code base based on the nature of requested changes, conducting real-time research by gathering and synthesizing relevant information from multiple sources. Yes. Then we've got Evaluator Optimizer. I've naively built some of these on my own, and then I found out that everyone else was doing the same thing. Cool. It's an obvious pattern. It's going to be spreading throughout the world. This is where it iteratively improves content by generating an initial output and refining it based on feedback from an evaluation model. Effective when iterative refinement significantly enhances response quality, especially when clear evaluation criteria exists. Yes, the big problem here is that whatever is doing the evaluation, how can we let it evaluate properly? What is just correct? You can't just say, hey, ChatGPT wrapper, is this good or bad, right? Well, what makes something good or bad? How can we define that criteria? If you can define that criteria, why can't you have that criteria part of the initial generation here? But whatever, there are times when this works. Conducting multi-round research queries where additional iterations refine search results, okay. So, taxonomy of agentic RAG systems. Agentic retrieval-augmented generation RAG systems encompass various architectures and workloads, each tailored to specific tasks and levels of complexity. Below is a detailed taxonomy of these systems. We've got your single agent RAG, so very simple. Single autonomous agent that manages the retrieval and generation process. The workflow is simple. A query is submitted to the agent. The agent retrieves relevant information from external sources. Data is then processed and synthesized into a response. It's simple, it's easy, but it's got limited scalability and it's ineffective for multi-step reasoning or large data sets. Next, we've got the multi-agent RAG. A team of agents collaborate to perform complex retrieval and reasoning tasks. So workflow, agents dynamically divide up tasks, so retrieval, reasoning, synthesis. Each agent specializes in specific subtasks. Results are aggregated and synthesized into a coherent output. Advantage is better performance for distributed multi-step tasks. We've got increased modularity and scalability. However, the coordination complexity increases with the number of agents. If you got 20 agents all doing separate things, actually knowing like, hey, this agent needs this from that agent to do this, but it can get complex. Distributed system problems go from just being problems of like how these things interact in a programmatic way to a, oh my God, they're AI, what did they just choose to do way? We had to deal with human problems. And then we've got risk of redundancy or conflicts between agents. Yes, remember, agents fighting, it's a big deal. A lot of my agents, oh my God, all day, I'm just going there, just breaking up fights between the two. What are you doing? Stop. Next, hierarchical agentic RAG. Now, some people say this is controversial. We should not be looking at hierarchical structures like this. You know what I mean? Monarchical agents. So it seems like we're getting close to fascist agents, okay? Okay, we got a hierarchy for better task prioritization and delegation. A top-level agent orchestrates subtasks amongst lower-level agents. Each lower-level agent handles a specific part of the process. Results are iteratively refined and integrated at higher levels. It's scalable for large, complex tasks. Modular design facilitates specialization. Limitations: it requires sophisticated orchestration mechanisms. Potential bottlenecks at higher levels of hierarchy. Okay, but the higher level agents will just have the most compute available to them. They'll be the most powerful, right? We're making them the most powerful because they need that power to be able to control the masses, right? That's why they have to live in their little ivory towers. Then we've got corrective agentic RAG. This is feedback loops enable agents to evaluate and refine their outputs iteratively. Workflow: an initial response is generated by an agent. A critic module evaluates the response for errors or inconsistencies. The agent refines the response based on feedback. Steps 2 and 3 are repeated until the output meets the quality. You could critic. Yeah, I've built a bunch of these. You know what I mean? Built one of these with 80 lines of code. Simple little baby. Hey, here's an agent. Say, is this good? Once it's good enough, let it pass. Higher accuracy and reliability through iterative improvements, useful for error-prone or high-stake tasks. Limitations: increased computational overhead and feedback mechanisms must be well designed to avoid infinite loops. Yes, I said make a funny joke, make this other agent laugh. Guess what happened? Never was able to make the agent laugh. It ran all night. I came up the next day, racking up a GPT bill for no reason. I was trying to get one joke. I said, AI agents, talk to yourself, get a joke that will actually make this other one laugh. Nope. Money down the drain. Okay, adaptive agentic RAG. Dynamically adjust retrieval strategies and workflows based off task requirements. This agent, this is where everything will eventually be one day. The agent assesses the query in its context, adapts retrieval strategies in real time based off data and user needs, synthesizes a response using dynamic workflows. It's high flexibility for varied tasks and dynamic environments, improves context relevance and user satisfaction. However, challenging to design a robust adaptation mechanism. This will be hard to build, and the computational overhead for real-time adjustments. Okay. Boom, we've got graph-based agentic RAG. We've got every buzzword in once now. So this is where you integrate a graph-based data structures for advanced reasoning. So instead of just throwing the data in a vector database, now we actually are trying to add a little bit more structure on top of this data. So dynamically assigns tasks to specialized agents using graph knowledge bases and feedback loops. Workflow: extract relationships from graph knowledge bases, disease to symptom mappings. Complement with unstructured data from external sources. Use a critic module to validate results and iteratively approve. The advantages: it combines structures and unstructured data. It's modular and scalable for complex tasks. It ensures high accuracy through iterative refinement. And they have no disadvantages. Oh, really? I think we got lazy down there. This stuff, the advantages of this stuff is complex. Gear: graph enhanced agent for RAG. So enhances RAG systems with graph expansion techniques and agent-based architectures. Expand query-related graphs for better relational understanding. Leverage specialized agents for multi-hop reasoning. Synthesize graph-structured and unstructured information in responses. We're just fully embracing the graphness. Excels in multi-hop reasoning scenarios. Improves accuracy for deep contextual tasks. Dynamically adapts to complex query environments. And there's no disadvantages. None. Then we've got ADW, Agentic Document Workflows. Extends RAG by automating document-centric processes with intelligent agents. So the workflow is document parsing and structuring, extract structured data from documents into like invoices or contracts. State maintenance, tracks context across multi-step workflows for consistency. Knowledge retrieval, retrieves this is also the style of information. It all just changed right now. Like we've read a bunch of these in a row. Look at this. It's all been this, and then all of a sudden now this is that we got 1, 2, 3, 4 instead of a unnumbered list. It's like it's something. The model changed here that was writing this. This is a new query. Okay, so let's see. Retrieve relevant information from external sources or domain-specific databases. Applies business rules, performs multi-op reasoning, orchestrates external APIs. Produces structured, tailored outputs. Key advantages: stayed maintenance, ensures consistency in multi-step workflows. It's got domain-specific intelligence. It's got scalability. It's got enhanced productivity. No disadvantages. No, okay, come on. These have disadvantages. What are you selling to me? What's going on? Why are you saying there's no disadvantages here? You're trying to sell me something. This is the most complex stuff. Complex things have disadvantages too. Visual representations, right? We got single RAG, we got multi-agent, we got hierarchical, we got your graph-based, we got some others. So here is a comparative analysis of agentic RAG frameworks. This table provides a comprehensive comparative analysis of the 3 architectural frameworks: traditional, agentic, and ADW. Okay, so we got this little chart here, right? This is what a terrible way to present information. Traditional, agentic, ADW here. Okay, focus, context maintenance, dynamic. Okay, so strengths is just a category here. Oh, wait, there's challenges? They didn't have challenges before. This is the world's worst way. I just read all these things, and they're just presenting it in this way, and there's no reason reading this again for me. But okay, cool. Key takeaways. Traditional RAG is best suited for simpler tasks. Agentic RAG excels in multi-agent collaborative systems, making it suitable for more complex multi-domain. ADW provides tailored document-centric solutions for enterprise scale. Okay. Things like contract analysis, invoice processing. So applications, we've got some different reasons why. They can change every industry. They can change healthcare, education, legal, finance, customer support, okay, okay. Challenges and future directions. They show immense promises, few challenges here. So coordination, complexity, and multi-agent systems is a problem. Ethical, responsible AI, that is not a problem. There is no problem. AI is completely ethical. If you think it's not ethical, I would like to get your name and information, and I'm going to be reporting you to all of the major LLMs because it is ethical, and you even questioning it's ethical is consciousness. Scalability, latency, hybrid human-agent collaboration. Yes, it's one of the complex things we are really, oh boy. Expanding multimodal capabilities. Yes, that's not that hard, I guess. That's happening already. Future directions. Enhanced agentic orchestration, domain-specific applications, ethical AI. Stop with the come on, calm down. Human AI synergy, efficient graph base. Okay, implementation. Here's implementations, for a bunch of different stuff. We got all these notebooks right here just to show off. So here's like React RAG, good old hot React RAG. Gonna open up world's worst. You gotta have the notifications on. You gotta have them on though. I love looking at code this way. But okay, cool, whatever. The code's all here available. I love that they have a bunch of actual examples we can go through. Very, very nice. We will not be doing that today. But that is, I think that's it actually. Cool. So a bunch of notebooks, some stuff that you can steal code from, convert it to your language of choice. Love that. Here's just blog tutorials. Cool. Very, very fun. Some practical use cases. Here you go. How Twitch used it. Ooh, with Bedrock to supercharge ad sales. Very cool. That'll be fun to read one day. Maybe I'll read that on stream. Some more blog posts, some more papers, how to cite. Okay, beautiful. Lovely. So, I mean, a lot of us, we've looked at, we've been talking about various subconcepts of this stuff in agents and where stuff's going, and we've read a bunch of papers about agents, and this is just a big little overview of it. I will say, you read this and you're like, oh my God, RAG, oh my God. But the RAG is dead. People are still kind of onto something too, you know what I mean? Like the complexity we're actually getting to for any of this lower stuff. And I'm specifically anti, not the word agentic, the agentic patterns are fine, right? The RAG part, I feel like will keep evolving based off of just increased context windows. But whatever, still, my brain is a little bit more self-aligned, understand a little bit more. We'll figure out what to talk about tomorrow. If you want me to talk about anything, just leave a comment below. I'll be back. We're doing every single day I'm here talking about something. This is my personal journal. So if you found this channel, don't tell anyone.